Okay, good morning. Welcome back to Calculus 2. So we are going to try to figure out the interval and radius of convergence for the series sum goes from n, the sum of n goes from 1 to infinity of x to the n divided by n. First, you might look at this and say, what the heck am I supposed to do with this? Let's go ahead and try our old friend, the ratio test. So what I'm going to do is I'm going to say try ratio test, right? And again, the thought is that we're going to go ahead and check the absolute value of a sub n's. We have to see whether or not the limit, once I applied the ratio test, is going to go to zero. Okay, so that's kind of the idea here. So let's go ahead and do this. We have x to the n plus 1 over n plus 1. And we're going to say divided by x over n. Okay, or x to the n rather over n. And that's our ratio test. Well, there's not a lot of algebra that we need to do with this. It's just going to be x times x to the n. That's what x to the n plus 1 means, over n plus 1. And then we're going to invert and multiply over here. So we're going to say this is going to be n over x to the n, x n over x to the n. So we have n over x to the n here. So this is all going to cancel out. And I just reversed the order here. So the x to the n's are going to cancel. Okay, and that's really the only thing we can cancel. So I'm left with, we have x times n over n plus 1. Now, if I take my limit here, right, limit as n goes off to infinity, so it doesn't have anything to do with x, we can kind of factor the x out. So put the x over here, times n over n plus 1. This limit is going to go pretty much to 1, right? So we have n over n, and we can multiply everybody by 1 over n here, 1 over n. So we have 1 over 1 plus 1 over n. As n goes off to infinity, we end up with a limit of 1. Okay, which tells me that we have an inconclusive test. However, we still have this term out here, this x term out here. So if this x term is going to, we're going to multiply this in. If this x term is somewhere between -1 and +1, then we'll have a convergence series. Okay. But I set x to be 1, right? So we have to check the endpoints. So check our endpoints here. Okay. So it's always a good idea to do this. So just double check it and make sure. So if x is going to be 1, then we're going to be able to say that we have 1 times n over n plus 1. And pretty much we end up with a limit of 1. And this doesn't really help anything. Um, Effectively, we have kind of like, yeah, this doesn't really do anything for us. So x equals 1 is not going to be included. Okay, so no, don't keep this. Okay, let's try -1. So we have -1 times n over n plus 1. We pretty much have, it's -1 raised to the nth power, right? That's what this is going to look like because it's x to the n for what's going to happen up here. So I go all the way back up here and I plug in x equals 1, right? So if we look at this, we'll have 1 to the n over n. When x was 1, this is just a harmonic series. This diverges, so clearly x equals 1 is not included. What if x is equal to -1? Okay, so if x is equal to -1, we're going to have -1 raised to the n over n, which is the alternating harmonic series. Okay, and then again, we can go back and say, well, it's an alternating series. We can go check our little conditions here. Is, we'll have, it really is an alternating series. So we check the zero condition. It's alternating. It is a series. Okay. So is my 1 over n's, are these all positive? They sure are. Is 1 over n a decreasing function? We can double check it. We could say f of x is equal to x to the -1, different x. Okay. Maybe we use t. Okay. And then say f prime of t, okay, is going to be negative t to the -2. This is a decreasing function, so 1 over n decreases. Okay. Does the limit go to 0? This is why it's weird to look at the harmonic series and say, oh, this actually diverges. Just because the limit goes to 0 doesn't mean your series converges. Okay, that's a very common mistake. So that's something you have to really be careful about. So my limit as n goes to infinity of 1 over n goes to zero. It sure does. So it passes all three conditions for my alternating series test. And alternating, if it does pass all of those, then the alternating series test converges. So my range of convergences, so radius of convergence is one, r is equal to one, centered at zero. Okay. And then what we're going to say is zero less than or equal to x, strictly less than one. Okay, so this would be my answer for like, what is my interval of convergence? X has to be between -1 include, but strictly less than +1. Okay, so that one's a little bit tricky because you have to check the endpoints. You usually do with these problems. So try to make sure you're checking endpoints, and then all of your serious stuff comes back. All of the different tests come back to like, does it work if you have to check all of those things. Okay, I'm going to say thank you very much for watching the video. I'll see you in the next one and take care until then.